Introduction to caps and plugs. Size, colour and material are the most important questions to consider. Where caps and plugs are used for protection, bright colours provide visibility. Where caps and plugs remain on, the colour needs to be less visible and match the application. The materials our products are made of each have different advantages. How do you know which material you should use for your application? To give you a head start, here's a quick look at common materials for caps and plugs. Low-cost LDPE is firm and is good at absorbing sudden knocks or force, which is why it's mostly used to protect applications in transit. In lower temperatures, it works well. However, in higher temperatures over 80 degrees Celsius, it quickly becomes soft. Stiffer and stronger than LDPE, HDPE has good resistance to chemicals and at preventing gases from passing through the material. Polyamide, commonly known as nylon, is a tough material with good thermal and chemical resistance. It's able to withstand temperatures of up to 180 degrees Fahrenheit or 82 degrees Celsius and is often used for masking internal threads. As plugs, they form a protective seal, making them a popular choice for masking. Ethylene vinyl acetate, EVA, is flexible even in low temperatures, providing a tighter fit than the previous materials, but with similar chemical resistance. It's excellent at protecting applications from dust ingress and damage. Polypropylene, PP, is cost-effective. This tough material provides good impact strength, but with some flexibility. It's great at retaining its shape after a lot of use, without suffering stress-cracking problems. Polyvinyl chloride, or PVC for short, is very durable. It's also flexible, providing an excellent seal. It won't crack or shred easily, and it can also withstand high temperatures. Thermoplastic elastomer, or TPE, is considered more of a rubber because it's dense, flexible and soft. With excellent weather resistance, it also doesn't tear easily under friction and has high impact strength. Nitrile has excellent resistance to oils and fuels. It also doesn't deform in shape easily and doesn't tear readily under friction or scraping. Because of its low resistance to UV rays, nitrile works best for indoor applications.